Hi and welcome to this little and short tutorial. During the next few minutes I'll try to create a clump of grass. There are many different approaches, and during the following course we'll take a look at two of those approaches. First, start with the leaf component. Just drag it onto the root camera. You'll have to zoom into the scene so that you can see this leaf component. Activate it by left clicking so that you can get the attributes in the parameter editor. First, I want to change the length to about 1.5, and then we'll change the shape, change the type from range to spline, and click Edit Shape. You'll get a new window and drag all control points out to the right so that we get a more or less rectangular shape. This is important because we'll use a bitmap with embedded alpha channel later on, and the bitmap itself will create the outline. To avoid distortions of the texture, we'll have to go with a rectangular shape, otherwise at the tip and at the base the bitmap would be squashed. In my eyes, the single blade is still too broad, so we either could change the ratio by increasing the length or by reducing scale X, for example. So this is something that, well, roughly looks like a blade. As next step, we'll take a look at the primitive tab. Primitive tab type is set to area. And now we'll turn the profile on. You'll get a new button. Now edit points. And here we'll create a V-like shape so that our grass blade gets a little bit more depth. Something like this. Well, and now actually I just apply a material. So go to the Material tab, set texture, and click Browse, and use the grass blade texture. You'll notice that the grass blade fits perfectly on our geometry. This is the case because scale V is set to the same value as the segment number. If we now wanted our grass blade to have a little bit more polygons to get a smoother shape later on, we could increase the number of segments. But then you'll notice, I'll turn off the y-axis for now. Then you'll notice that the texture will be repeated several times along the length of our grass blade. So in this case we just would have to set scale V to 10. So scale V should be the same as segment number if you want the bitmap to fit exactly on the geometry. Now go back to the leaf settings. We have three parameters right here which help us to control the rotation of our leaf component. By default, we directly enter the value which is used to rotate our geometry, but we'll change this relationship to R&D, which stands for random. And now you'll notice that the leaf starts to rotate in a randomly manner. We have two values right here. The first one defines the strength at the base and the second one at the tip. I'll do the same for rotation Y and also for rotation Z. If this is too strong, then we easily can change those values later on. And of course, our grass blade should be influenced by gravitation, so I'll increase the gravitropism parameter, something like this. We can fine-tune this later on. So this is our first step. We built a simple grass blade. Perhaps we could make it a little bit thinner something like this. And I think this looks pretty nice. So we can go on with the next step by creating a clump out of this single grass blade. To create a clump, we need an object that multiplies our grass blade. We'll use the feeball for that, the taxes object. Just drag the feeball onto the root camera, then drag the leaf component on the taxes, and you see we already have some sort of clump. We'll adjust some of the parameters. First of all, I'll reduce the radius. Then we'll work on the opening angle. The parameter is fan. Just use the lower slider. You can think of a arc which is made of those two parameters. The first is the opening angle here at the top. The second one is the angle at the bottom. So if we now reduce the difference between those two, we'll move up the grass blades in the upper area. So this already looks pretty nice. You can see we have many grass blades arranged in a clump. Because of the random rotation, all grass blades look slightly different. You can see that we have a poly count of 1900 triangles. We'll try to reduce that. Of course, you could work on the leaf or the leaf component itself, reduce the number of segments. For now, I'll just reduce the number of grass blades created by the feedball, so that we have something like this. And during the next step, I'll show you how to increase the density, the volume of this grass clump without increasing the polygon count too much. For now, I'll rename the components that we have. This is our first feeball, so I'll call it feeball 1. This is our single grass blade. I'll just call it grass blade. And save this scene. Please add a horn component to the scene by adding it to the root camera. You'll notice that the horn component is a lot bigger compared to our grass clump. So I'll activate it, go for the basic settings, choose log scale, and reduce the scale of this horn component so that it roughly matches the rest of our clump. Probably okay, so that's fine. Now go for the primitive settings, change the primitive type from tube to area. Now our horn component also has a flat profile. Increase scale X to about, well, I guess it should be about 10. And then go back to the regular horn settings, change the number of segments to about 3. And then go for the shape parameter. We have a cosine function. Applied cosine of 0 is the max value of the cosine function, returns a value of 1. This returns a value of 0, and you can see the result in our shape right here. We have the max width at the base, where we have a result of 1, and a width of 0, where we have a result of 0 at the top. I want a square shape, so I simply change this to cosine of 0. Another way would be to change the function to ID. That's easier if you are not into math, and just enter 1 and 1, one at the base, one at the top. And now we, with the horn component, we have this option called top. By default it's turned on. Now I'll turn it off, and now we have a perfect rectangular shape. I think I'll reduce the length a little bit, so this is pretty nice. And now we'll apply a bitmap to this geometry. So go for the material settings, set texture, and this time use the grass billboard texture. You'll notice I'll hide the rest of the scene for now. You'll see that the bitmap is repeated several times. This is because we have a segment count of 3, and our scale V is set to 1, so this should be 3. And now the bitmap exactly fits on top of the geometry. Of course, we could have done something similar with the help of a leaf component, but I wanted to show you that other components also can be made into a leaf simply by changing the primitive type. And another advantage of the horn component over the leaf component is the possibility to turn the top off. You notice that when taking a look at the shape of the leaf component, it's not possible to move the topmost point, so you'll always have a tip at the top of the leaf of the grass blade. The horn component allows us to turn the top off, so we can get a perfect rectangular shape. And this was one of the main reasons why I chose the horn component in this case. So now it's time to multiply this horn component. Again, I'll use a phi-ball. I'll rename this phi-ball to phi-ball 2. Drag the horn component on top of the phi-ball. Again, we'll have to change some of the parameters. I'll reduce the number, the radius, and of course again the opening angle to something like this. You can see that this geometry only produces 84 triangles and looks actually pretty detailed. Now we go for the rotation parameters. We'll use rotation X to bend the this low poly geometry. You have to be careful because the rotation parameters of the horn component are very sensitive. So you can see that with very low values we already have a pretty high rotation. As you can see, it's a little bit hard to really work with the sliders because of those tiny values. But if you double click this range value of our parameter, you can simply change the range of the sliders. So now it's much easier to use the sliders to create the desired curvature. So we have something like this. And now we'll take a look at the phi-ball settings and go for the scale parameter. We'll use a function in here. Actually, I changed the scale function to custom. In here I'll type 1. So the low poly geometry exactly receives a size of 1. But now I'll add another equation. I'll add random function of x. This makes it possible to use those sliders right here to pass a value to the random function which is then added on top of the value of 1. So now you can well, easily change this value, and so well, add a certain random value to the default size of 1. I also changed the influence value, which tries to move the instances according to their size. So in areas, if this is set to 1, in areas where we have small clumps, those will be packed tighter together, and in areas where we have a big object, this object will receive more space. And if we reduce this value, then they are placed, and it doesn't matter how big or how small those little instances are. So this random function inside the scale helped us to well, create much more variations inside this low poly geometry. And now we'll simply turn on the visibility. We unhide our other grass blades, and you can see that we added a lot of density. I think we can increase the size of the low poly geometry. Probably a little bit more. So now we have a combination of low poly geometry, which adds a lot of density, and then we have our detailed grass blades, which give us a more realistic look. And as a result, we get a pretty nice patch of grass. Now I'll just rename the horn component to something more meaningful, like grass clump, or you also could say low poly grass or whatever. So actually this is all you have to do to create a simple patch of grass. You'll notice that the polygon count is not too high. We still would have potential to lower this polygon count by reducing the number of segments of the grass blade. We also could change the ratio using less of the detailed grass blades and more of the low poly grass blades or clumps to well, get a dense and realistic look without increasing the polygon count, or even with going using a low polygon count that we have right now. So this simple hierarchy is enough to build this detailed patch of grass. And you also learned that it's sometimes useful to use a horn component instead of the leaf component. And I guess now it's time for you to play around with the different parameters and create your custom clumps of grass. Thanks for watching.